Welcome back, everyone. Before I do anything, let's check and see which one we're at now. So now we're at video number 10. That means that after this, we have 2 more videos in this block before we switch to the next item. Okay, right-click on the event game system object and select delete. So we don't need that, I guess. Delete. Next, you'll see use the 2 remaining game object canvas and image to create the fade effect. Mark step is completed. It is completed. Hit the start on my timer because I keep forgetting. Alright. Configure the canvas. In the hierarchy, rename the canvas to fader canvas. Rename this to fader canvas. Okay. You should notice that its transform component is different to the ones you've seen before. Let's see something here. Oh, okay. Game objects that are part of the UI system need better control over their position, so have a rect transform component. For canvas at the root of the UI hierarchy, the rect transform settings are read-only. Okay, fine. The canvas component controls how the UI elements which belong to that canvas are rendered. The rendering is primarily controlled by the render mode setting. It has 3 potential modes. Screen space, overlay, where the canvas fills the screen and all the UI elements of the canvas are rendered on top of everything else. Screen space, camera, where the canvas fills the screen but is rendered to a specific camera and subject to distance from the camera. World space, where the UI exists in the scene and is rendered in front or behind objects, for example, name tags of characters in the 3D world. You need to stretch an image across the screen and have it rendered over the top of everything else. So that means the default render mode of screen space overlay is perfect for you, which it already is. The next component on the fader canvas game object is canvas scaler. Okay, this is used as an easy way of controlling the relative size of the UI elements when they're displayed on the screen on different screen sizes. Your image will be stretched across the entire screen, so you don't need to worry about the relative scale. Click the cog icon on the top right of the canvas scaler component to open the context menu and click remove component. So we're going to remove the canvas scaler. Remove component. Okay. The final component of the fader canvas game object is the graphic raycaster. This is used to detect UI events such as clicks. It will determine which UI element was clicked on and send the event to the element so the appropriate component can react. The player won't need to interact with the UI in your game, so this component is not needed. Click on the icon on the right of the graphic raycaster component to open the context menu and select remove component. Alright, so remove component. Alright, let's mark that as completed. Stretch the image. Alright, the next step is to stretch the image across the screen. In the hierarchy, select the image game object. Image. Select the rect tool from the toolbar or press T. Rect tool, rect tool, rect. We're already on the rect tool. In fact, hold on, something funny is going on here. Why is the image not where the rect tool says it is? This is because the scene window is using the post-processing you set up in the previous tutorial. Click on the effects button in the scene window to enable all the effects, then click it again to disable all the effects. So, what's that? Click on the effects button in the scene window. The effects, is that this one? Do we know? Interesting. Neat. Now your image should display properly. Cool. Rect step is completed. Alrighty. Completed. Explore the rect transform component. Let's have a closer look at the rect transform component. A 3D game object's position is presented by a single point at the game object's pivot. The position of this pivot in a transform component is relative to the game object's parent. Rect transforms work similarly, but since the UI elements can represent an area, there are some differences. Instead of the position of a rect transform being relative to a single pivot point on their parent, they are relative to an area of their parent. The area of the parent is represented by the rect transform's anchors. You may have also seen a gizmo in the scene which looks like a flower, or a fan, or a propeller, or something. This is actually multiple points all pulled together. Each of these points is an anchor. The rectangle created by the 4 anchor points is a proportion of the total area of the parent. Your image is a child of the fader cam which fills the entire screen. That means that your image's position is relative to an area of the entire screen. The position UI element is measured in pixels. This is very important, particularly because not all screens have the same number of pixels. This is what makes the anchor system so powerful. When these anchors are all together, they show a point. The rect transform shows a position in pixels that the UI element is offset from that point. And you're starting to lose me here. However, if the anchor separated from the rect transform shows a pixel offset from the sides of the anchor area, like so. So how does this apply to your game? Well, you need the whole screen to fade. That means your image should cover the entire screen no matter what the screen size, shape, or size is. In order to achieve this, you need to make sure that the anchor area is the entire screen and there's no offset from that area. Okay, so you're going to tell me how to do that, right? Configure the rect transform component. To configure the rect transform component, let me take off my glasses here for a little bit. Let's see. Let's see. In the hierarchy window, select the image game object. In the inspector, find the rect transform component. Right. Expand the anchor setting. Expanding anchors. Set the minimum values for x and y to 0. Set the maximum x and y to 1. Min, max. 0, 0, 0, 1, 1. Okay. Remember, the anchors are relative to their parent. 0 means the far left or bottom of the screen. 1 means the far right or top of the screen. Okay, no problem. Now that you've set the anchors, you should see that your image position has changed. The position is now listed as left top. Wait. Oh. Left top. Pos Z, right and bottom. Apart from pos Z, which you can ignore, these are the distance of the game object from its anchor area in pixels. A negative value indicates the element is outside the anchor area. A value of 0 means no offset from the anchor area. Okay. In the example above, the left side of the image is 394 pixels from the left side of the anchor area. The right side is 942. The top is 47, and the bottom is image is 145 pixels from the bottom of the anchor area. Okay. So, given that the anchor area of your image is now the whole screen, no offset is needed. On the image rect transform, set the left, top, right, and bottom properties to 0. So, oops. What? Oh, it did it. Okay, fine. 0, 0, 0, 0, 0. Look at that. Check it out. Now it's covering the whole thing, right? The image now stretch over the screen. This image is the right size now, but it's not the right color. In the inspector, find the image component, which I'm on. Let's see. Right, image component. The first property is called source image. This allows you to display specific picture is left blank, then get a rectangle of solid color. This can be set with the color property. Open the color picker, set the RGB channels to 0, leaving A at maximum 1 if they're in 0 to 1 or 255. This will set the color to black. Okay, so let's do that. I think we're supposed to be on RGB, so right. Set the RGB panels to 0, leaving A at maximum. Right. Okay. 0, 0, 0. Okay. Problem? A is the fourth channel, making up color alpha. The alpha color is how transparent it is. The lower that, the more transparent it is. It will be the key to make it fade in and out. Click elsewhere in the editor to close the picker window. Now you have a fully black screen. We'll see. Okay, so that's going to be the end of this video, and I want to thank you for watching, and I want you to catch me on the next one so that we may continue on.